All right, ICS321. We are on this day, Chapter 6. So, constraints and predicates. And so this is the last sort of academic theoretical chapter, because after this we're going to start actually doing this stuff for real on using MySQL. And all these concepts that we sort of went over up here, we are going to actually see how we implement them. And constraints and predicates are exactly for triggers. We implement constraints and predicates that cannot be implemented by some sort of enforcement of a primitive type. We can enforce that some number is, not greater than 128 because it's a binary number, but we can't enforce that a number is greater than 100. Between 0 and 100, you can't really enforce that with a primitive type. So what you need to do is put a little dinky little program in the table that you want to do the insert, and every time that there is an insert, you look at it to make sure that it follows the business rule that you're implementing. So, it was interesting because I was working on a database problem this weekend, and it had to do with when I buy a voter file, I need to update my voter database product. I sell subscription service to a website where, if you're running for office, the website allows you to print out voter lists in all the different kinds of formats that you would use to do a campaign, like knocking on doors and do mailings and so on. And I had this bug where when I updated, I got a new voter file, and what I do is I separate the addresses with the names that go with those addresses, and I link them using keys, a foreign key, and when somebody moves, so this new system was put in place this just in January because the state of Hawaii changed how they sell the voter file. So I got a voter file in February, and then I got a voter file a couple months ago, and the addresses, the residential addresses weren't getting updated. The residents for people that moved. Now, there were only 23,000 people that moved in those 3 months, so it didn't come up very often, but a couple folks who used it noticed it and contacted me. And so when I was trying to figure out how to update that table and how it's all connected, I found a real convenient way for me to picture that problem was using image relations. And I just thought, because I had just taught it to you guys, and normally I don't think about that when I'm doing my real world stuff, but it happened to be a perfect example, and I can't remember it offhand well enough to explain it to you. But so this stuff does kind of come in handy, and for you folks, since you supposedly are learning the relational algebra stuff first, and then you're going to dive into the SQL, but I imagine a lot of you have seen SQL before. You may just very well think about solutions to database problems using some of these techniques like matching and so on, that if you just come up in the database world, you don't really think like that. So anyway, let's go to the textbook. I'll both go to the textbook, and I will go to the quiz, because the quiz is taken from the textbook. Must be this one. I suppose I can open up the slides also. Do I have the slides in here? Or this is 321. I don't think I have the slides in here. Okay, so that means I gotta go to my, do I have them in here? Okay, well I have them online, right? You know, this is the first, every year or so, I would say every semester, but like every year for about the last 3 years, when I first found out about, when I first really figured out what OneDrive was, I tried to use OneDrive. Is it in here? We are in Chapter 6. I downloaded it already. Oh well. I've tried to use OneDrive because I work on different computers. And this semester I tried it again, and sure enough, it works real well now. For some reason, I must have speeded up or got bugs out of it or something. But I do stuff at home before I come here. Well, I do now I do all the stuff on my computer at home, and I can just come here and get right in. And pretty soon I'm probably going to start leaving this computer at my other office. And I bought a new Dell, a light one, and that should come this week. And hopefully I can just connect into the cloud. But anyway, I can now recommend it. Before I didn't. All right, so let's get into integrity constraints here. Integrity constraints. An integrity constraint is a Boolean expression that must evaluate to true. Okay, so any attempt to update a database in such a way that would cause some constraint to evaluate to false must fail, and it must fail immediately, and it must be such that when it's done failing, the database is in a correct state. Okay, so that might mean rejecting the operation. And there's various ways that it has to handle it, because sometimes you don't find out that something has to be rejected until you've actually done a couple updates or something, and then you go, whoa, whoops, this isn't going to work, and so you got to back out of it. And so database management systems offer ways for you to control that and to do that. So some constraints in SQL can be implemented directly by the database management system without your having to go and do writing logic, writing a sequence of operations with decisions in them. But you just have to still connect it up to configure it, and that's like keys and foreign keys. But here's an example of some constraints that we might decide to have, and these are called business business rules or business constraints, because it's sort of in the business that it has to do with what the application of the database, the context of the use of the database, and not so much where this is a phone number, so it's got to be 10 digits, and it can't be less, it can't be more. It's not like a constraint like that. For example, let's say you wanted to enforce this range. Okay, so what we're going to start by doing. Okay, so here's what's important in this chapter: to be able to write those kinds of expressions. Okay, because these kinds of expressions come very close to how you actually implement them in SQL, or it defines it, in a short, unambiguous statement or expression what would need to be implemented in the trigger for the database, for the S database. And so here we've defined a constraint, and we just give it a name, CX1, and we say that the result of this operation, of this expression, has got to be empty. In other words, there can't be anything that's returned. There can't be any tuples. S where status is less than 1 or greater than 100. If and so an operation like this could be, I guess you'd think of this as an operation that would be done after the insert. If you were to actually implement this the way it looks, it would be an after the insert. And so you can't. I don't think you can reverse an operation that was just done in a trigger. You need a transaction to do that. The way you actually would implement this is you, before the insertion took place, you would not let any records be inserted in there where the status was less than 1 or the status was greater than 100. So it would be a before insert thing. It would also need to be a before update thing. Okay. So the second thing that we have to learn out of this chapter is to identify what operations on tables we need to look at to enforce this constraint. And so a constraint like this, where it's got to be where there's never a tuple in there in the S table with the status outside the range of 1 to 100. That would be what database operations could possibly violate that constraint, and that would be an insert, in addition to the S table, if you added a new supplier in there, or if you updated the S table, namely you updated the status of some supplier to less than 100. You got upset with some supplier and you just wanted to make it a 0, so that would be an update. The supplier's already in there. So those two operations, you would need to, those two operations on S would be where we would need to look to enforce a constraint like this. This is another way of writing it. This is a more easier way to write it, which translates to SQL. And what it is this constraint is S, where status is greater than, it's got this and this. This and this is a kind of a way of looking at this. But it's this and this, where you have S, and then you also have status is greater than or equal to 1, or status is less than or equal to 100. And could reasonably be pronounced for all. For all S, this. For all S, that. Okay. And so here's one where all suppliers in London must have a status of 20. So for all S, the city is either can't be London, or the city is, or the status has to equal 20. Do you see that this is like the same as this, or the inverse of this? And the way you can do that, the way you can tell is the way you can mechanically verify it is all of the equals become not equals, all the ands become ors, all the less thans become greater than or equal to, and all the greater thans become less than or equal to. They reverse like that, and then that's how you know they're equal. Right? Then they're equal. Here's one where supplier numbers must be unique. So if you add up the number of tuples in S, you get some number. And if you take the projection of just SNO on of S and count those up, the only way you can get the same number as this, because this we're talking about a relation. If it's a relation and there were duplicates, it would be a smaller number, right? The only way they can be equal is if each one of the SNOs has to be unique. Otherwise, if it were a relation, it would you'd only see one of them. So this is a roundabout way of stating or enforcing or constraining, but the system really doesn't do it this way. But this is how you can confirm. It's one way of confirming. All right. So here's where suppliers with status less than 20 aren't allowed to supply Part 6. So status less than 20, okay, is empty. When you join S with SP, there should be no P&Os in the P&O equals 6, where the status of that supplier tuple, matching supplier tuple, is less than 20. Let's see, this might be a good time to just go over here and take a look at the quiz. The quiz would be in, let's go here. Okay, so I can show you both 10 and 11 because they're the same kind of thing. All right, they're both the same problem. The first one is you just state which database, either insert, update, or delete. Those are the three database statements, operations that can change something. You just have to say, you just need to list the operations. Like for parts can't weigh more than 100, okay, well that's, insertion into P could violate that constraint, so you got to put some code in there to make sure it doesn't. And updating a tuple in P could violate this, so you got to make sure that it doesn't happen. But it doesn't have anything to do with S. It doesn't have anything to do with SP. Something like this has something to do with the P and SP, because to be able to figure out if the shipment weight is 10,000 or less, you need both the quantity in SP and the part weight in P, and so you got to do something like this join thing, something like this. So parts that can't weigh more than 100. Shippers shipping quantities greater than 1,000 in a single shipment must have a status at least 30. Okay, so there you have to go look at the SP table. Maximum shipment weight is 10,000. There again, you have to look at parts table and SP table. Screws from SNO equals S2 are not allowed. This is actually, in the previous version of this quiz, I actually had the name of the supplier, but then that would suggest that you need to also join in the supplier table because you want to get at the name. This is simply parts and SP, so these actually get a little bit more difficult, because it involves two tables. Screws from S2 are not allowed. So you have to. So if you update the parts table, it can affect this because you could change some P&O that wasn't a screw to a screw. Some P&O that's being shipped by S2. And that's not a P&O equals 3 or something. Let's say it's not screws, and then S2 is shipping it, and then you go in there and you change the part. It's from nuts to screws, and then boom, you all of a sudden are violating this. So you got to put the code in there, and so this becomes a little bit more tricky. And basically, what you're doing is you're identifying where you're going to put the trigger for when we're doing triggers for SQL, which come later. And I think one of the there's a video or something. One of study.com talks a little about triggers. I mean, they're such simple concepts that they can you can learn it all in 8 minutes. And it's all it is. The only hard part is remembering the syntax of SQL procedural language. It's not Java. It's not even. It's kind of like PL1. PL1 was IBM's first attempt at a structured language where there was if then else. Algol was the first European one. Anyway, so that's what you need to do. You just identify the tables for these 5 things. Suppliers can only ship parts from their city. So in this one, you treat the city, the supplier's city, and the part city. You want those. You want to actually look at those and make sure they're the same. If you're gonna have a constraint like this, you're gonna say suppliers can only ship parts from if they're in the same city. Why? I don't know. I don't know. For some reason you might have a constraint like that. So that's that. And then for quiz 11, it's simply the same thing except for I ask you to write the constraint statements. It's the same thing. But you write the constraint statements. So a good way to look at that is to that's chapter 6, and so if you go to up. So these, it's helpful. When I write these quizzes, I just spend 2 or 3 hours reading these exercises in the back, and I come up with some clever variation of them to make sure you understand the concept. But to understand the concept, you start to see the patterns and the similarities between my question and the question here, because it gives you the answers, you see. So you look at the question, you look at the answers, you read what he says, and you are able to, it should help you. It should help you learn. I mean, you should be able to learn this stuff from several different directions. There's his video, there's this book, and I also give you this other textbook here, which is, do I give you that other textbook? Yeah, this textbook here is the same textbook, the same content, except for it's way thicker, and it does not assume that you don't know SQL. It assumes you do know SQL. It assumes you're a programmer and you know SQL. And this book here, there's actually a sequel to it, or a second part of it, which is I Got It, and it goes. It's like it continues on, talks about fifth normal form and join dependencies and so on. More constraints that you can have on systems, on relations. And what's nice about this one here is when it talks about a concept, it explains how to do it in SQL right in the same chapter or maybe the next chapter. So that's a good, if you become interested in something, you can go further into here. All right, so let me, this is no two suppliers can be located in the same, oh, that's different than the last one. Oh, here, supplier S1 and part P1 must never be in the same. I guess that's kind of similar. You've got suppliers and parts. So this here is suppliers shipping parts from the same city. Because if you join S and P, this is the sort of the parts that suppliers can ship if the shipper and the part has to be in the same city. And you're doing a natural join on city here, and you're just taking out the P and P and O and the S and O. So anyway, okay, so this is where S join SP, the status less than 20, and for parts P6 is probably a particular quality issue or something. Every supplier number in SP must also appear in S every supplier number in SP. This is just the foreign key constraint. This is if you look at the projection of SNOs from SP, they have to be a subset of all the SNOs in S. It can be equal, or it can be a subset, but it can't be. There cannot be anything here that's not in here. There cannot be any tuple in this. A tuple only has one attribute, but there can't be an SNO tuple that is not in this set. Let's see. Way of thinking about, very important way of thinking of rel bars. The heading corresponds to a predicate. Supplier SNO is under supplier SNO is under contract. Is under contract. Is named S name. Has a status of status and is located in a city. The parameters are those. The tuples represent true propositions. Okay, so this is a way of looking at what a rel bar is, and it's rel bar because it's something that's exists. It's a variable that has real data in it, and so it's like, of all of the possible combinations of SNO, SNAME, status, and city, of all the different possible kinds of values that there can be, the only ones that are really valid are the ones that are here in this rel bar. So this is saying that the tuples in a rel bar represent true propositions, true instances, or true instantiations of the predicate, which is the header, and that which would evaluate to true, because it's there. If it's not there, it's not true. It's not true that it's there, that it exists. So there is an S1 named Smith. There is a supplier named S1 whose name is Smith, whose status is 20 and is located in London. How do we know that that's true? Because that is in that's a tuple in the rel bar. Every rel bar has an associated rel bar predicate, which would be the heading or meaning or intended interpretation or intention. That's right, this word. The only time I've ever seen this word is in this chapter. But it's like the intended interpretation. It's like, as he says, SNO is under contract, is named S name is under contract because it's a supplier in this company's table. This company's got a table of suppliers, or it's got this table of suppliers, and so a supplier being in there means he's under contract with you because he's in there. He's got a contract number, a supplier number, and a name and a status and a city. And so that is the intention of, that's what the predicate, that's the intention of the predicate. Intention. Intention with an S. If rel bar R has predicate P, then every tuple T in R at time X represents proposition P, derived by invoking or instantiating P at the time X with T's attribute values and arguments. Yeah, it's just another way of saying sort of the same thing. All right, this isn't that important. It's important to go through this and think about it once and kind of see where they're coming from and seeing how this fits with this kind of language. Parsimonious, if you're an academic, it makes you feel good. Relations versus types. Types are sets of things we can talk about. Relations are actually two true statements about those things. It's the same as types and variables. You know, you have a type integer, which you talk about integers, but then you have a variable that's an integer, and that actually has something in it. Types and relations are both necessary. They're not the same thing, and they're sufficient. Having to do with databases. Okay, so relvar predicate for R is, and that's just the header. You know, got the names of the attributes in there, and you know what they mean. R is the intended interpretation for R, but it and corresponds to, but it, you know, but it cannot be understood by the system. And where this is leading is you know, this has all been set up, but the system cannot really enforce truth, only consistency. So you have to try to take as much advantage of the structure, but it's still up to you to you know, to be the ultimate, you know, interpreter of truth. You know, I mean, it may or may not be true that statuses can only be between 1 and 100. You know, maybe you do have a status of 105. Well, you know, that's the database doesn't know that. All you've done is you want them to be consistently between 1 and 100, and so it can enforce. So that's kind of the point there. Correct implies consistent, but consistency does not imply correctness. So here are the exercises, I think, in the back of the book, back of the chapter. And so, does he give answers? No, he doesn't give answers here. Okay, so if we, you know, we might as well. It's kind of early, so why don't I just do a view here and 2-page. This is fine. Let me make this bigger. Okay, so give plausible predicates for P and SP. Parts might be all the parts that we need to purchase at some time or another in the inventory and in the business that we have, the business that we do. We need these parts, and these are all the parts that we need. When I had the first time I actually tried to start a company and actually, you know, make $1 million and all that, it was in the 80s, you know, and IBM had just came out with a personal computer, and I had about 2 years before, I had actually some guy hired me to make a memory board to plug into an Apple computer, you know, an Apple II Plus, and 16K, expanded it from 48K to 64K, and then when IBM came out, so me and my buddy, he had just graduated in electrical engineering, and I just graduated in computer science and was going to graduate school at the time. But so we designed 256K memory expansion boards for the IBM PC. And the only reason I'm telling you this is because we had to learn about all this inventory management. I mean, we finally said, oh, we better write it all down, and they didn't have spreadsheets back then, right? Because this was, you know, VisiCalc was a spreadsheet, so we didn't do that, but we had to keep track of our inventory and part numbers. So we have these parts, and these parts are supplied by our suppliers, and it's all of them. So that can be, you're basically coming up with relevant predicates. I have messed around with the predicates, relevant predicates for SP. Sometimes I say that they're shipping, that's what's shipping this week, or that's what has shipped this month, or that's what's in transit at the moment. And so that's what you're supposed to do here, but there's not a question like that back for this quiz. But here there are. Consider the constraints and suppliers, and what are we supposed to do? Which operations have the potential to violate these constraints? You do not need to give your answer very precisely, just insert on S or something. So here and she gives the answers back here, but oh, do I need to? But so here's the insert on S, update on status in S, or equivalent assignments. So that's the kind of thing. Supplier status values must range between a range of 1 and 100. Okay, so we have the supplier table here, table of suppliers, and when you're making these constraints, or you're making these triggers in SQL, in MySQL, you'll see this. You know, there'll be an assignment. There'll be an assignment 4 or something like this. You're allowed one before insert, one after insert, one before update, one after update, one before delete, and one after delete. That's 6. Okay, so you're allowed 6 different places to put trigger code, and that trigger code has got to handle all the triggers for that type of thing. So, you know, the on insert, or the before insert is usually a very busy trigger. The before update is a very busy trigger because you want to stop it from happening before it happens. So this would be, you know, inserting, insert on S because you don't want to insert something that's out of this range, and then update on S because you don't want to update a range. You don't want to update a status that's outside this range. And suppliers in London must have a status 20. Inserting, you have to have the trigger there before you insert, and you can't. Before you update any supplier that's in London, if you got to make sure that you're not updating, changing the status, and also any city of a supplier, because you can't take a supplier that was in Paris who's got a status of 30 and then change that supplier to London, because then you'd have a supplier from London that's not status equal to 20. So those are so you have to put the check there. What do I say? Insert on S, update on status, or city in S. Sure, yeah. That's what I said. Supplier numbers must be unique. Well, that's just, you make something because you want the supplier numbers to be a key, to be a primary key. What does it say here? What are you supposed to do to keep it from? You have to. You can never update. Okay, if you're going to update a supplier number, you got to look at that. When you're going to insert into S, you got to make sure you insert an SNO that's not already in there. Suppliers with status less than 20 must not supply part P6. Okay, so there's probably lots of them there. You have to be careful when you're updating any supplier's status, and you have to join it with SP to make sure that supplier is not supplying P6. If the supplier's supplying P6, then you gotta look to make sure that you're not changing the status to something less than 20. If the supplier's supplying some part other than P6, then it doesn't matter, but you still have to check. Now, I don't think you have to worry about the parts table, because you can't really change. I mean, changing the part number of P6 to something else when you set up that constraint, that it's a foreign key in SP, you would say that at that point you would say whether or not P6 can change. You can make it where if for some reason you want to change P6 to P06 because you decide you're going to have more than 10 parts or something in P06, you can set it up so you change P6 to P06 in the parts table, and it automatically changes it in the SP table. It goes there and it changes all the P6s to P06s. But anyway, nonetheless, in this case, you got to look at all the places where some part can change into P6, and some status can change. Some status can change, and that supplier is supplying P6. Every supplier in SP must also appear in S. Okay, that's the constraint that you can't have any orphans or to do that. That's what to do this, to enforce this. You have to be careful when you add something to SP and when you delete something from S. When you delete a supplier, you have to make sure that that supplier is not currently shipping something. And when you insert a new shipment into SP, you have to make sure that the supplier exists in the S table. Insert on SP, update SNO in SP. Oh yeah, forgot about that one. Update SNO in S. This does say that you got to worry about if you update P&O. Okay. All right, and then 6.3 is to write the constraints for this. You see, 6.3 is it's a different set, but I tell you to do the same set. Write constraint statements for the supplier parts database for the following business rules. Now, all red parts must weigh less than 50. Oh, okay. Well, anyway, this is Wednesday's quiz, so why don't I just I need to have something to talk about on Wednesday, so why don't I postpone this to then. And next week I'm going to have your first assignment. After this week is over, you should be all done with your videos. The study.com, it doesn't matter. You until the end of the semester, and they're very short. You can bang a bunch of them off. Bang a bunch of them off in an afternoon, easy. And so there'll be an assignment, and so we'll start getting assignments and SQL and doing that sort of more fun stuff. So are there any questions? All right, I'll shut this down, and you can come up and ask me questions if you have any. Let's see, did anybody have a question here? No. All right, thanks for watching.